Hey everyone, my name is Shashank Shekhar, Master Teacher of Mathematics at Vedantu. Here we are presenting solutions for JEE Advanced 2018 Paper 1. In this video, I have taken question from the limit topic. In fact, it will be converted into finally definite integrals. Let's see how can we do this. For each positive integer n, let yn is defined as 1 by n under bracket n plus 1, n plus 2 till n plus n whole raised power n. 1 by n is outside here. For x belongs to capital R, real numbers, let box x be greatest integer less than or equal to x. If limit of y in n tending to infinity is equal to capital L, then the value of box of L, that is greatest integer less than or equal to L. So how can we solve it in easier manner? See, the approach one is to get the value of L directly and getting then greatest integer less than or equal to L. Approach 2, I will tell you that how can we solve without finding L here and getting the answer for greatest integer less than or equal to L. So let's see. Right. So one by one, both the approaches. So yn here is given as n plus, if I take this 1 by n out inside this bracket, so n plus 1, then n plus 2 till n plus n upon n raised power n whole raised power 1 by n. If we take the log here, then log to the base e, I can write 1 by n, and log of product, we know that after taking log, this product can be converted into sum. So we'll get log of n plus 1 by n, that is 1 plus 1 by n, plus log of n 1 plus 2 by n, and so on, log of 1 plus n by n. So right, now apply limit n tending to infinity log of yn to the base e as limit n tending to infinity 1 by n sigma log of 1 plus, I can write r by n, r ranging from 1 to n. Now we know from the concept definite integration as a limit of a sum, that we can convert it into an integration. In the left, I can write log of limit of, I can take this limit inside this log is continuous function, right? So we can take it inside. So we know from the composition of, the idea of limit of composition of function, we can write the left hand side as this, and in the right hand side we can convert it into, we replace r by n by x and the limit sigma symbol by integration sign, log of 1 plus x, and the limit would be from 0 to 1, isn't it? So 1 by n replaced by dx, and we know the integration of log 1 plus x as 1 plus x, or you can put 1 plus x as t, then you'll get integration ln t dt, and the limit should be from 1 to 2, or you can directly in the similar manner integrate log of 1 plus x using by parts. By taking 1 as second function, you'll get 1 plus x log of 1 plus x minus 1 plus x, and by putting, after putting limit 0 and 1, you'll get here at 1 it is 2 log 2 minus, by putting 1 it is 2, and at 0 it is log 1 is 0, but here you'll get minus of at 0 it is minus 1. So finally we are getting okay, so 2 log 2 plus 2 log 2 minus 1, 2 log 2 minus 1. So we are getting log of L, because L was defined as limit of yn n tending to infinity, 2 log 2 minus 1, 2 log 2 minus 1, 2 log 2 minus 1, which can be written as log of 4 upon e, isn't it? So finally we are getting L as, the value of L as 4 upon e, and in that manner the greatest integer less than or equal to L would be, because we know that e is E is close to 2.718. So 4 by E, greatest integer less than or equal to 4 by E would be 1. So final answer to this question must be 1, right? And another approach we can go for by common sense, by observing it, that we can say that okay, I am taking yn again. Yn, see carefully, yn is basically 1 plus 1 by 1 by n under bracket. Yeah, it was. So I'll show you how can we get the value, final value, without finding L here. The question, the answer can easily be tracked. Like yn is given as 1 by n, 1 n plus 1, n plus 2 till n plus n, whole raised power 1 by n, right? So can I write yn is more than, if I replace n plus 1, I mean n plus 2 by n plus 1. Obviously this is smaller. What I am writing is smaller than yn actually. So yn is more than this. I replace everything by n plus 1 here. N is positive. So finally in that manner I will get what? In this way, n plus 1 whole raised power n, whole raised power 1 by n, that is n plus 1 by n only. So 1 by n into n plus 1 easily, right? It is basically power n whole raised power 1 by n. So from here, and which is 1 by n, n plus 1, that is 1 plus 1 by n, and limit in that case, so L is, okay, limit yn n tending to infinity is more than limit of 1 plus 1 by n tending to infinity. That is, from here we can say that L is more than 1, because limit of 1 plus 1 by n tending to infinity. Similarly, yn is less than 1 by n if you replace every bracket by n plus n, because the largest term here is n plus n. So I am replacing it by n plus 1 whole raised power 1 by n. So here you will get 1 by n and n plus n, that is 2n whole raised power n whole raised power 1 by n is finally n plus n. So 2n by n is 2. So yn is less than 2 clearly. So limit of yn tending to infinity, L would be less than 2. So finally we are getting L as 1 between 1 and 2. So we can say that greatest integer of L would be just 1. So I hope you understood this method also. Without finding L, we can easily track the basic idea of, I mean, taking the basic things here, the brackets, the minimum and maximum value. So I hope you enjoyed it and understood the solution, right? So everything is typed here also. Thanks for watching. Stay tuned for the next question.